questions, they're very straightforward, and I may not necessarily give you the answer because you can have the answer and show it to you. I'm just going to show you what to do, okay? So, first question, you know, and when I set this up, the practice up, I set it as you can not only work it, but you can pause it and go back to it. And then I did not shift the question. So it should be every time you go back to it, you should see the same order of the question. Do you have the same question number 1 as I do?
Yeah. I mean, I'm just looking at what I wrote down.
Okay.
I can't see because I'm like on 26 or something. It won't let me go back.
Oh, no. Can you? Oh, it's okay. But can you see my screen?
Oh, yeah, I definitely can.
All right. So question number 1, a 0.5 kilogram ball is at the top of the ramp, which is 8 meters long. How much kinetic energy? So the key word here is kinetic energy. I am going to give you a list of formula you're going to use for the test. Okay? So if you remember what's kinetic energy, that's perfect. Kinetic energy, let me not use this. Can I use this? I guess not. So I'll just use this. Kinetic energy is equal to half mv squared. Right? All you have to do, what's m? 0.5. What's, oh, hold on. Oh, sorry.
That's the length.
Sorry. So this is m. Right? So yes, we're looking for kinetic energy, which is mv squared. However, here, it's not given to you the v, is giving you the height. Remember the conservation of energy, right? It says how much kinetic energy does the ball have at the bottom of the ramp? If you look at the picture here, this is the height, which is 8 meters, right? If you have a ball on top of here at rest, this ball has only potential energy, but with no kinetic energy, okay? 0 kinetic energy. But if the ball drop all the way to the ground, this ball will have 0 potential energy, but only kinetic energy. So basically, whatever it has the potential energy is equal to the kinetic energy here.
Yeah.
All right? So it's actually one of the simple problems we have in the practice.
Wait, so wouldn't it be like potential energy equals mgh? Like
Wait,
that's right. So yeah.
Can you let Abby in?
I am letting her in.
Oh, okay. Cool.
She has no patience. I just saw her name pop up. Okay. So potential energy is equivalent to kinetic energy. So potential energy, how come I hear nothing anymore? Oh, okay. All right. I thought I lost you guys. So it's mgh, right? And then your m is 0.5. Your g is 9.8. And then your h is 8. All you have to do is calculator and then put in the answer, right? Can I skip? Okay. Ooh. No, if I write it here, it's the same page. All right. Question number 2. A block of a mass that weight 0.5 kilograms. So mass is 0.5, right? And then with a speed, so velocity is 2 meters per second. On a smooth surface, it strikes another mass that is, okay, so this is a mass 1 and V1. It strikes another mass that is 1 kilogram, so M2 is 1 kilogram. And then they move together as one body. The energy lost during the collision is, so basically the energy, so the conservation of momentum does not give you the energy, right? So here, the collision, if it's inelastic collision, the momentum is conserved. However, the energy can be lost. So we have to V2 is a no. V3 actually is a no. So first, we have to find the velocity. We have to find the velocity after they collide, and then we can find energy. It's a two-step question. Yes, baby. 1 second. Boom, boom. Okay. So momentum, conservation momentum, it tells you the momentum of collision before MEV1 plus M2V2 equal to, since they move together, right, as one body, so M1 plus M2 times V3. V2, it seems like we don't know, but I'll just assume V2 is 0 because it didn't tell you. All right. So then you plug it in. M2, M1 V1 is 0.5 times 2 plus 1 times 0 is 0 equal to 0.5 plus 1 is 1.5 times V3. All right. So that gives you 1 equal 1.5 V3. So V3 is 1 divided by 1.5. 1 divided by 1.5 is equal to 0.67. Okay. And now we need to calculate energy before the collision and energy after the collision. So before the collision, it's kinetic energy, right? So before collision, kinetic energy of the first item plus kinetic energy of the second item is equal to half m1 v1 squared plus half m2 v2 squared. Okay, so if you plug in the number and put in the calculator, so m1 0.5 times 4 divided by 2 is 1 plus, seems it's v is 0, so it's 0.
Wait, what do we have to plug in? Like, you keep cutting out for me.
Oh.
I'm sorry.
So you see the screen, right? We have, so after we find it, using the conservation of momentum, we find out the velocity of when they together, the velocity, right? And then since we're looking for the energy lost, so we need to find the kinetic energy before collision and kinetic energy after collision. Does that make sense? So right now, I'm looking for the kinetic energy before collision in two separate items. KE1 is the kinetic energy of the first item, and KE2 is the kinetic energy of the second item. Since we already have the given, I just plug in the given, use the calculator, I find out the total kinetic energy is 1 before collision. Does that make sense? Okay, then you have to find out the kinetic energy after. Let me just find some space on the left side. So after collision, the kinetic energy is equal to, since they move together, right? So the mass, So it's half mv3. Sorry. Okay. So it's half times 1.5 because that's the mass together, right? And V3, what we find is 0.67, but it's a square. Okay, now you put in the calculator 1.5 times 0.67 squared divided by 2 is equal to 0.34. So how much energy is lost? You use it before, which is 1 joule, subtract the after, which is 0.34 joule, or maybe it's 3.33-ish. Your answer is C. Okay, so 1 minus 0.34. Yep, it's correct. Okay, next. Ooh. Every time I finish, I need to erase. Okay, so this is a true and false question. Total initial energy always equal to total final energy. Is it true? Is true or false, guys?
False.
Very good. Momentum is always conserved. How? Oh, hold on. Total initial energy is always equal to total final energy. Yeah, it's false. Because energy can be lost as heat. Let me see. Just like earlier question, you see energy can be lost, right? But momentum is always the same. So let's see false. Check it. It's true. I guess that. So.
I'm sorry. What was the answer for number 2?
0.67.
Okay.
Okay. The reason why this is true is because it talks about total energy. So earlier, the reason why the energy is lost is because we're talking about kinetic energy. The energy that's lost in the kinetic energy is converted to potential energy that caused the deformation. So in an closed system, energy and momentum both, the total amount of momentum and energy will always be equal to each other. Okay? All right. Let's look at number 4. A 65 kilogram girl is running at a speed of that 2.5. The kinetic energy of the girl is 150 joule. Is it correct? This is straightforward. All you have to do is using half mv squared.
Oh wait.
You plug in n, you plug in v, see if the answer is 150. If its answer is 150, true. Answer is not 150, false. So 65 times 2.5 times 2.5 divided by 2 is 20, is 203 actually. So it's not equal to 150, so it's false. False? Okay. All right. Next. So this is true or false? That is correct. Okay. Yep. It's like common sense. Okay. It's not going to be.